Solar eclipses are really the most famous of all the eclipses, but they're not the only kind of eclipse that's out there. The lunar eclipses are really much more commonly visible because what happens is for a solar eclipse, you have to be in exactly the right spot on the Earth, the exact spot where there's going to be an eclipse. And so if you're anywhere else, you don't see any eclipse. But for a lunar eclipse, then anywhere on the night half of the Earth can look up and see the moon in the sky. And so if the moon happens to be eclipsed, you're going to see it. Now, a lunar eclipse can be kind of similar to a solar eclipse. You could have a total lunar eclipse. So a total lunar eclipse, the moon passes right through the umbra of the Earth. Remember, we said the umbra is the darkest part of the shadow. That's where all the sunlight is blocked. And so the light, remember, the moon reflects sunlight. And so when you blot out the sun, then the moon starts to go dark. And so that would be a total solar or total lunar eclipse. Now, if the moon moves in such a way that only part of the moon gets into the umbra, then you get like a little bite taken out of the moon, and we call that a partial lunar eclipse. Now, there's one other kind of a lunar eclipse that can happen, and that is if the moon moves into the penumbra of Earth's shadow. Now remember, the penumbra is where some of the sunlight makes it, but then other parts of the sunlight are blocked. So that means that some of the sunlight, some of the light from the sun makes it past Earth, but not all of it. And so if you were on the moon, you would see a partial solar eclipse. But from Earth, what you see the moon is basically going to be less bright because part of the sunlight is blotted off. And so you just see the moon less bright. We call that a penumbral lunar eclipse. Penumbral lunar eclipses are pretty boring normally, unless the edge of the moon gets really close to the umbra, in which case a whole bunch of the sun's light is blotted, and that side of the moon looks darker than the other side. And so you'll sometimes notice that, but unless you have a deep penumbral eclipse, you don't really notice it. The wimpiest of all possible lunar eclipses is a partial penumbral eclipse, in which the moon moves by, so only part of the moon even enters the penumbra. And so all that you would ever notice would be that maybe one side of the moon is slightly less bright than the other. In fact, almost nobody would even notice a partial penumbral eclipse, and many people would never notice with the naked eye a penumbral eclipse at all. And so those are pretty boring eclipses to look at. So contact times. We talked about contact times with the solar eclipses. P1 is when the moon just enters the penumbra. So the one edge of the moon starts entering the penumbra. P2 is when the moon is completely inside the penumbra. And so that means that if anywhere on the moon, you'd see a total, or rather partial solar eclipse. U1 is when the edge of the moon enters the umbra, which is the total portion. So now, if you're on that part of the moon, you see a total solar eclipse. On other parts of the moon, you'd still see a partial solar eclipse. U2 is when the moon is completely inside the umbra. So at that point, then it's total lunar eclipse from Earth and total solar eclipse everywhere if you're standing in the moon. Now, it takes the moon a while to move, so it can take the moon quite a while sometimes to move across the Earth's shadow. Earth is much bigger than the moon, and so Earth's shadow takes a while. So the moon can get into totality, and it can sometimes take 30 minutes to an hour to cross the umbra to start coming out. And now when it starts to come out, then we call that U3. So U3 is when you start to end the total lunar eclipse. So up to that point, you're going into eclipse. Then U3 would start to leave the eclipse, okay, and so now it's a partial lunar eclipse. U4, the moon's completely out of the umbra. It's no longer even a partial eclipse. It's a penumbral eclipse still, because the moon's still in the penumbra. P3 is when the one edge of the moon starts to leave the penumbra, and then P4, the entire thing is over and done with, and you are completely out, and it's all over. Now, sometimes with a partial lunar eclipse, you will get P1, P2, U1, but you never get U2 or U3 because the moon never gets all the way in, and you just go straight to U4, where the moon gets uncovered by the shadow. For a penumbral lunar eclipse, then all you get is P1, P2, P3, and P4. Or the wimpiest of all things, a partial penumbral, you get a P1 and a P4, and you skip all the other parts. So, moon moving through the shadow of the Earth. So start the penumbral, start the umbral. So that's going to be your contact time of U1. That's going to be U2. That's going to be, sometimes they tell you the mid eclipse because that's when it's deepest. And then we get P3, P4, and then finally U4. Okay. Again, NASA puts these eclipse bulletins out. So January 2019, they had a total lunar eclipse, and so as the moon passed right through, it was actually visible from North America, and we actually had this set up on campus as extra credit opportunity, like the first week of the semester. We set up, and it was freezing cold out, we watched the whole thing beginning to end, and so lunar eclipses are kind of interesting because the lunar eclipses that we see tend to, you think, since the moon does not reflect any sunlight, the moon will be black. And that's not exactly the case. It turns out the moon turns a kind of an orangish color. So why would it do that? Well, think about what's happening. We've got the sun shining, we've got the Earth, and we've got the moon. Okay, and so the moon is in the shadow of the Earth, so the sunlight's blocked. But the day side of the Earth is here, towards the sun, and right there is twilight. So if you're standing on the moon, looking back towards the sun, instead of just seeing a inky blackness, you see a ring of twilight. And that ring of twilight, due to the Earth's atmosphere, shines on the moon, giving it this orangish, reddish, pinkish color. And so that's a hallmark of lunar eclipses. Now, the exact color that you get depends on lots of circumstances. It depends on how much air pollution Earth has at the moment, depends on volcanic activity, aerosols kicked up by volcanoes, depends a little bit on season, pollen, things like that, depends on humidity. So it's really very dependent on Earth's atmosphere. And so it does make for this reddish sort of color right there. And that ring of twilight is doing it. André Danjon, a French astronomer, came up with a scale for measuring just how deep this eclipse would be, and we call it the Danjon eclipse scale. And L0 is when the moon is so dark it's almost invisible, and L4 is so bright it doesn't even look all that eclipsed. And then in between, it's kind of like an L2, which is kind of a blood red color. In fact, in the ancient world, they referred to the moon as like turning to blood or bleeding, and they would freak out because the moon looked bloody red as if it had been wounded or something during that kind of an eclipse.